one technical hiccup to figure out on the YouTube end, and oh, it looks like we're live actually there, so we should be good to go. Welcome to everyone on YouTube. Let's get started in 30 seconds.
Okay, we'll get started in 1 minute. Should we get started?
Yeah, let's do it. Welcome everyone.
Let's do it. My music has stopped. Right? You guys don't hear it?
Yes. Yeah.
Okay, sounds good. Cool. Well, yeah, everyone, thanks for coming. Vadim, do you want to share your screen?
I believe it's being
Oh,
shared.
you
Can you
are
guys see
sharing
it?
your screen. I see it. I
Awesome.
see it. Yeah, just have to click a button. Yeah, so cool, everyone. Thanks for coming. Excited to have you all here today. Today, kind of as a continuation of our past live streams, we're going to be talking a little bit more about OpenTelemetry, but specifically about the .NET ecosystem. Um, a little bit of background on why we think this is important and why we're sort of doubling down on these types of SDKs and the .NET ecosystem is that we've become a lot more active in the like Azure and .NET ecosystem recently. And as a function of that, we've also onboarded a lot of customers there that have been giving us a lot of really good feedback. And so we thought, what better way to sort of spread the love than just talk a little bit more about it in a more public setting and teach people more about the ecosystem. If we quickly go to the next slide, we will be talking today about the following topics. First, we'll be going over just observability, what it is, and why it's important in the .NET ecosystem. Then we'll be covering what OpenTelemetry guarantees you in the .NET ecosystem, as well as what might be missing. And then we'll finalize things by kind of going over an actual demo of a real .NET like production application and how it sends data to Highlight, and then what that data looks like in the OpenTelemetry realm. So overall, really excited to get into that. But before we do that, let's start by just doing a quick round of intros, and I'll start on that front. My name is Jay, and I run the product team here at Highlight. And so I'm responsible for a lot of the product decisions that we make, as well as a lot of the relationships with our customers. And yeah, excited to be emceeing this today and good to meet everyone. Over to Vadim.
Hey everyone, I'm Vadim. I run the engineering team here at Highlight. The .NET ecosystem has really been something that, as Jay mentioned, we're really focusing on and has been an exciting avenue for us to have folks understanding more about their system. So excited to be sharing all this with you and giving you a nice demo later today. And I'll hand it over to Chris.
Hey there, I'm Chris Schmitz, calling from Wisconsin, and I am an engineer on the Highlight team here. I've worked on a lot of our OpenTelemetry tooling. Just pushed an update to the Ruby SDK today. We just shipped an integration with the browser OpenTelemetry that I've been working on. So it's fun to see some of these things come to life and get these things into our customers' hands, and continue to iterate and on their feedback. So thanks to everyone for being here, and excited to share about some of the things we've been working on.
Cool. So with that, I will maybe turn it over to Chris again to talk a little bit about just observability at a high level and how that's relevant to folks in the .NET ecosystem.
Yeah.
Sorry, Chris.
No, I could have ran with that. My bad.
Okay.
Before we dive deeper into observability, I think, the definition of observability for me for a long time was very vague, and it could mean maybe different meanings for different people depending on, who I was chatting to in the context. So just to make sure we all have kind of the same idea in our head, I wanted to share this definition of observability that I really like. And it is the ability to understand what's happening inside a system by analyzing the data it produces. So with that definition in mind, let's talk a little bit about, to kind of emphasize the importance of observability. Let's imagine life without any observability for a little while. So imagine that you're working at a SaaS company. It's a scaling company. You're building a CRM tool. And users start complaining about features not working, or it being having seeing jank in the app or lag. How would you go about investigating that? So you get a customer report. If you don't have any data about what's happening in your systems, it's really hard to even know where to start. You can talk to the customer, you can ask them to retrace their steps, maybe have them jump on a screen share, and then maybe you can see what was happening in their browser. But it's really hard to understand, what's going on, especially if you have a distributed system. After that button gets clicked, what's happening maybe on your server that is causing that issue that's manifesting itself as, the page kind of being frozen or, lag across the app. So if we go to the next slide here. So one thing without observability, there's, I think, a few kind of characteristics of kind of poor observability. One, and I can actually speak to all of these from kind of lived experience, in my years as a software engineer, working as a consultant and working with dozens of different engineering teams. But one is, if you don't have this visibility, you have to rely on your customers to report issues. You end up being reactive to someone complaining that something doesn't work. Another thing is scattered data. So you might have some logs, you might have some some traces or some of these diagnostics, but they might be all over the place. They might be on a machine, like in a file, and not something that's accessible to you that's integrated into your troubleshooting workflows. There's a lot of guesswork. All you can do is really test something out and see if that fixes the issue. And often you'll do that on a development system. And when you deploy to production, the issue still isn't fixed, especially if it's a performance problem. There's lots of blind spots. You lack visibility into systems and the interactions between them, causing you to just completely miss issues. This, of course, results in taking much longer to fix an issue, extended downtime, if anything. If your app is actually down, and also finally, there's just uncertainty to even know, did my change make a difference? Am I certain that this issue is even resolved? And in contrast, if we think about life with observability, I think there's two categories of benefits here. So first we'll talk about the developer experience benefits. So as someone troubleshooting applications, one big shift is you can move from reactive to proactive notifications. If you have the right monitoring system in place, you can be proactively notified that you need to look into something, a performance hotspot, a bug, etc. Another thing you get is clear analytics. So you can understand, is this an issue that is isolated for a single customer, or is this having a pretty broad impact across our entire user base to decide how to what priority this issue should be. Another thing is you get full visibility into your system. You can know all the code that executes, how many times it executed, how long it took. You have detailed product analytics, and you get all of this data in real time. Another thing is that data is connected. It's cohesive across all of your distributed systems. So something that happened in the browser, you know that a click happened, and you can track that all the way down to maybe a database query on the other end of that might be causing non-performant or an N+1 query that's causing end user issues with lag. Of course, with all this information, you get much faster root cause identification of understanding, okay, this is the actual issue. You can look at something like a flame graph, which we'll talk about later. And you can quickly see, okay, this is the bit of code that's taking a long time to execute. And then you can see as different parts of the code get hit, you can understand, did an error happen here? How long did this execution take, et cetera? Or even if it's an external API, to understand if that's the bottleneck. And then finally, I mentioned, uncertainty about whether an issue is even resolved. Having objective results is really, really helpful to know. Like I deployed this change, it should fix the issue, and I can actually watch a graph that shows maybe database performance time or request time or network request time and I can see that graph come down to objectively know that I improved performance by this, or this bug stopped being reported. So that's the developer experience side of things, but I think there's also a number of important business impacting benefits as well. So if you think about just the bottom line of your business, why is it important to have this? Why should you be investing in this type of developer tooling? I mean, one, of course, faster fixes, quicker problem resolution, reduces downtime for customers, and smoother user experience here. So that results, in more reliable, responsive platform, keeping customers happy. Increased efficiency because teams can spend less time troubleshooting and worrying that the system might not be performing the way it is. They can find those bugs and fix them a lot faster, and that allows teams to spend more time innovating. Reduce churn, of course, just kind of bottom line, like when people aren't satisfied with an app, I mean, the speed matters, bugs matter, and of course, customers have a lot of options these days, and if your app isn't performing the way they expect it to, they're going to look for other alternatives. Of course, this results in cost savings, fewer incidents, quicker fixes, lower operational expenses, and then, of course, better informed decisions. So all the data coming from your app, you have those product analytics, and you can lean on that, as we do at Highlight, really heavily to make better informed decisions as a team about where to focus your efforts. So with that understanding of observability and why we think it's important, I'm going to kick it back to Jay to talk a little bit about OpenTelemetry and collecting the data needed for a good observability setup.
Thanks, Chris. And so, yeah, on that note, before we get into OpenTelemetry specifically, I just want to kind of talk about historically what have been the top 3 observability pillars or types of data that you would send from your application. Just to kind of give you an overview of all the things that Chris talked about in terms of benefits, how do we actually start implementing that into our application, right? So the first is logs. And logs are basically arbitrary events that happen in your system. What that means is when in Python, you call the print function, or you use like a proper logging library and you send some data across, or in maybe C++ if you're using the logging library in C++. All of the data that you're using to kind of like diagnose your application at specific steps, those we consider logs and are part of the OpenTelemetry, which I'll get into in a second, schema in terms of the data being sent across. The second are metrics, and these are basically just time series based numbers that you send within your application. For the most part, these numbers are actually sent from like your containers and the infrastructure, that their underlying infrastructure that's sent over. But there are some solutions where you can actually send data from the application as well. But that's also an observability pillar that you can then create metrics and alerts from. And then the last is traces. And the way we like to think about traces is they're essentially like logs, but there are two things that are different. One is there are actually relationships between traces. So a given trace can have a parent or a child to denote some sort of hierarchy in terms of what is being executed at a more and more or less and less granular level. And then a duration. And so traces have actually like a start time and an end time. And that helps you understand how fast a specific operation is. So here on the bottom right, you can actually see that there is a flame graph of traces. And at the top, there's a high level trace. And at the bottom, there are sort of more granular traces as well. Yeah, those are the top, like the three observability pillars. One thing that isn't included here is like front end observability, which we'll get towards the end. But this is what's included in OpenTelemetry. So if we jump to the next slide, before I get into OpenTelemetry specifically, I'm going to ask a quick poll to the audience. So it's a very simple question, but I just want to get an idea of what folks' familiarity with OpenTelemetry is. And I'll give it just like 30 seconds to a minute for folks to kind of come in and share some thoughts. Looks like we got a lot of mediumly familiar people with OpenTelemetry. Looks like we're waiting on one person to answer. Give it like a 5 seconds. If not, no worries. Okay, cool. So yeah, in general, it seems like people are sort of familiar with OpenTelemetry. And so I'll kind of go a little deeper in terms of what it is and what the project is about. So OpenTelemetry is an open source project that is maintained by the CNCF. And that's the Cloud Native Computing Foundation. We actually have a YouTube video on exactly what OpenTelemetry is, and it goes very deep that we can share at the end of maybe on the last slide of the presentation. Yeah, it's an open source project that's maintained by a team of folks from a lot of large companies. And essentially what it is a specification for sending logs, traces, and metrics. And all it is basically, yeah, what data is being sent for each resource or pillar, as well as how you would name those things and conventions around it. And the second thing that I'll say though is that it is used, and a lot of companies ingest that data, highlight included. And the nice thing about that as like a consumer or a developer is that if you're sending data to any of these vendors, you actually have a lot of optionality now in terms of what vendor you want to choose and choosing the right vendor. So just want to kind of bring that up in case y'all are currently using a proprietary SDK. There are lots of benefits to using OpenTelemetry in that vein. Let's jump to the next question. Okay, and then in terms of the ecosystem, beyond just the specification, there have been projects that have spun out as sort of additional resources around the project that support all of the SDKs that make it easy to send that specification across the wire. So for example, there is a Python OpenTelemetry SDK that you could install in your Python application and then send the data to whatever vendor that you would want to choose. That way, you don't have to actually write the code to abide by that specification yourself. It is worth noting, though, that OpenTelemetry in and of itself is just a specification. So if you wanted to make your own Python SDK, that would be totally fine as well. So it gives you a lot of optionality in that sense. Beyond that, there are other instrumentations just beyond code level instrumentations, like for databases and for frameworks. And there is an OpenTelemetry collector, which can sit next to your actual containers in case you don't want to do any application level collecting as well. So there are lots of ways that you can actually send the data at the end of the day. And the ecosystem around OpenTelemetry for those sort of sources for sending data is only growing. Okay, now I'll quickly talk to why OpenTelemetry is relevant in the .NET ecosystem and what the current ecosystem looks like as well. So as I mentioned at the beginning of the conversation, the Highlight team is actually very involved when it comes to the Azure ecosystem. And we have a lot of customers that have used historically the Azure application monitoring tooling. So we're familiar with that. And the two big tools in that space are one, Application Insights, and two, Azure Monitor. For those that actually, this is a great time for a poll. Okay, quick poll for the audience about how familiar you are with Application Insights in Azure Monitor. Okay, it looks like we have a good amount of people that are less familiar with it. Okay, I'll go ahead and end the poll. Okay, David says used it a little bit, but not much. Got it, understood. So yeah, just a quick overview, and I won't go too deep here, but Application Insights is essentially a tool for logging and tracing. So you can send the logs and traces we mentioned earlier on those pillars to your Application Insights dashboards, and then you can just search across logs and search across traces. And then Azure Monitor is more so for actually monitoring and alerting on those types of resources. In general, those tools are pretty strong. Like they're actually quite good because the nice thing is you actually install, you don't have to do much work once you install something on Azure and you start building an application. But there are some missing parts of it that we'll kind of go over time. But in general, that's the extent to which the default .NET ecosystem uses OpenTelemetry, because Application Insights, for example, does accept traces and logs from OpenTelemetry. And so, yeah, given that, let's jump into OpenTelemetry in practice. And then maybe towards the end, I'll talk a little bit more about the differences between Application Insights and what Vadim is about to share.
Awesome. Thank you, Jay. Yeah, so what I'm going to be sharing is an open source .NET example application published by .NET. You can find it on our GitHub as well as a fork with what I'm going to be showing set up. But yeah, this is a project that encompasses multiple different microservices using a .NET Aspire workload. So there's a number of microservices, including some background workers that process async messages out of a RabbitMQ pipe. There's the web app itself that handles the front end via Blazor. There's backend service APIs that communicate with other services as well. So this is an example app that's going to be like a real world application. And we're going to be showing you what that data will look like. The example app itself is a e-commerce example. So just with some dummy data, stock data that we're going to be taking a look at. So let me just show you first what the app will look like. We're going to walk through using it a little bit, and then we'll play back a session in Highlight using all that data collected with our SDKs using OpenTelemetry and digging into it. So this is the example application, just an e-commerce app, as you can imagine. We can add stuff to a shopping bag. We can view a shopping bag. All of this is powered, as I said, by .NET Core with Blazor on the front end. And with server-side rendering using Blazor. Once I check out, I can place an order. That's going to hit the backend APIs, submit an order here, which is going to get processed via that background queue. So again, this is an MIT licensed open source app called eShop. You guys can check it out. And that's not really what the focus is here, but the focus is on how OpenTelemetry can then give us deep insights into what a user was doing in your site, both from an aggregate perspective to understand how people are using your site and what's going on the server, but also for the support use case to dig into a particular customer's request to understand what might have gone wrong. So let's switch over to Highlight, where I'm going to be looking at one of my earlier recordings today. What I'm going to be starting with is the session replay. That's the front-end observability piece that Jay mentioned earlier, where we can play back what the user was doing granularly over time. So I have a session here where I was loading just the orders page. I can see myself moving my mouse cursor, scrolling around, switching to the orders tab, loading the shopping bag. In another session, I have an example of me actually making the purchase. So I'm adding some items to my cart. All at the same time, the front end is making requests to the backend eShop API. We're able to capture that using the network request panel. So this is showing us the individual requests that are being made by the front end to the Blazor backend, to the .NET backend, and capturing the full request and response bodies, as well as all the headers. So this is all captured using our JavaScript snippet. But OpenTelemetry comes in on the server because we're able to capture spans for code that's running both on the browser and for code that's running on the server. So when some operation is executing on the server, we can see a sub span. So this is the request as it was initiated by the browser, hitting the server at a particular time after some network delay. And my server has emitted a span that's showing a bunch of additional attributes that can help with debugging. So now I can understand, okay, at this point in time, when the person clicked on this particular button, the browser made a request to this API endpoint and the server executed the following code. Well, that's great. But let's dig into it a little bit further by starting with the data that's on the server. So to do that, we can jump into the traces viewer. And now we have a list of all of the spans that are being emitted by OpenTelemetry by the instrumentation on the eShop codebase. So what we have here is each of these being a span over the last, well, this is actually current because there's data being emitted constantly by the background orders worker. You can see the different services here emitting spans being labeled each individually. I'm going to make a query here just to look for data from the web app. I'm going to take a look at a different time range to load some data from earlier in the day. And I'm going to take a look at some of the APIs that were being hit, like the checkout API. So at one point, we made a post request. That post request was actually submitting the checkout flow from one of my sessions. I can search for that span directly since I know that that's what I'm interested in. So I can search for post/checkout, put this in quotes, and that'll give me all of the instances where I was checking out. And when I was doing that, I have a session replay recorded associated with that checkout. So earlier today, I was making a checkout flow. I can see that session where I was checking out. And as I play through it, I'll be able to navigate to the point in time where I was actually making the new order and checking out. So it's going to be later in the session, but yeah, we have that ability to tie data together. And once we open up one of these spans, we see all of the rest of the code that's executing server side that's attributed to this entire trace. What does it mean to have other data in the trace? Well, there's the entry point to the code, which is the actual API route. And as part of that, we're hitting another microservice, the orders microservice. And that orders microservice is actually handling the transactions in the database in Postgres to make sure that my order can be fulfilled and that there's inventory. So I can actually see the individual SQL queries in C# that we're executing as part of another microservice. So that data was connected together by virtue of the .NET OpenTelemetry client auto instrumentation. Kind of a mouthful there in terms of how many terms we have. But yeah, the OpenTelemetry SDK is automatically associating microservice requests by passing through the trace header from service to servers. So that's how we can tie together things across different microservices, and stitch everything together as part of this one particular flame graph. So that can be really useful because now, let's say I'm trying to understand a performance issue for some APM. So I'm trying to look for all of my, let's say I'm looking for all of those SQL queries, and I want to find the slowest ones. The way that I would do that is by graphing the latency, the duration of those queries. And I can simply sort by the duration and see the slowest one taking 200 milliseconds earlier in the last hour. Now, by clicking it open, I can see what was going on and the actual SQL query that resulted in that. So now I have a clue as to a particular index that could be, that might need to be optimized in my .NET app and what was triggering all of this. So again, by playing back the session, I can see what was the user doing on the front end that initiated that request. I can again find it via the network tab and go in the other direction as well. So a bit on that example app in terms of the tracing, that's kind of the high level. One other thing I want to mention before we jump back into an explanation of how we did all of this is our high level metrics visualization. So all of that data that's being captured from OpenTelemetry can then be graphed as a time series or aggregated as a table to understand where are my outliers and what's in particular going on at a particular point in time. So let's say I'm looking at the last 4 hours of data and grouping the latency of all of my spans by service. Now I can say, here are all of the gRPC operations that are happening. Let me figure out which is the slowest service. And when I do have a slow service, I can actually inspect that particular one. This is the web app at 4 seconds, and look at the individual spans that were that slow and figure out why they were that slow. So I have quite a bit more insight into looking at that and visualizing data from that perspective. So I might understand that, hey, the checkout flow is actually the slowest operation. Lastly, the data is fully structured when it's ingested into Highlight. So all of the OpenTelemetry attributes you might be sending, they're all indexed and filterable and aggregatable. So what that means is that you don't have to worry about how much data you're sending and what you're going to be doing with the different attributes that are associated on your logs and on your traces. You can, at the time that you need to investigate an issue, be able to query that and see all of the data that's being sent over by grouping that data. So in this case, I have a graph of my latency for all of my gRPC operations, and I'm grouping by the gRPC operation to understand which one is the slow one. That said, I'll transition a little bit into the final piece of the front-end observability, which is the session replay client and the JavaScript snippet that's installed into the Blazor HTML code. That's what gives us the session replay capability, but that also gives us a lot of metadata about user sessions. So let's say I'm trying to understand what page of my app are most users spending time on, or if there are other requests that the front end is making to other APIs that I don't have control over, how long are those taking? All of that is aggregated and sent over into Highlight via OpenTelemetry and is visualizable in the same interface. So how did we do all of this? With .NET, the .NET ecosystem is actually very OpenTelemetry friendly, and there's a few ways to accomplish this. First, with application insights, there's actually a no-code instrumentation that you can use to set up OpenTelemetry. The way that would work is by using the OpenTelemetry NuGet package, by installing it, and by setting up some environment variables that will automatically start piping data over. So for application insights, it's as simple as that. You'll get auto instrumentation, but you won't be able to emit custom spans or log custom data from your code. So with that, we can transition to the actual OpenTelemetry SDK example. So if you're trying to have a more custom setup where you need to control the types of instrumentations you achieve or the attributes that are sent over in order to send more structured data, you can do that by setting up the OpenTelemetry SDKs at the code level, configuring the OTLP destination endpoint that I have right here as an example, and additional attributes that you might need. But this is quite a bit of code and can be a little bit overwhelming to configure, especially when you have to understand the OpenTelemetry destination and what the OpenTelemetry data looks like, what are attributes that you might need to send over. With a Highlight SDK, we have a NuGet package We have some docs here that will show you more information, but the NuGet package will do everything that the OpenTelemetry SDK is doing. It'll set up OpenTelemetry, it'll set up the destination for you, and set up all those auto instrumentations that we were just showing. So that eShop app that we had instrumented was actually using the Highlight SDK, and the Highlight SDK is just setting up OpenTelemetry for you in a simpler way. I think we had a question here in the chat about Blazor WASM. And yeah, there's quite a bit of ways to set up OpenTelemetry in the front end. So that's actually what we're going to be talking about next. How we instrument spans from the browser side if we want to associate data that's happening server side. Let's say clicks, or let's say mouse focuses on particular DOM elements, or other kinds of loading operations that are happening on the browser. So the way that that's done, OpenTelemetry WebJS is the JavaScript version of OpenTelemetry that's compatible with the browser runtime. And it's actually associating the spans that are emitted via OpenTelemetry's exporter protocol by attributing them to server-side rendering via the trace parent context propagation. So the W3C trace parent propagation is a spec that's part of OpenTelemetry that allows you to propagate the context of code executing on the server to the browser and continue the trace there. So just to dig further into that and what that means, when you load example.com, let's say that's the site we're talking about, the browser is making an HTTP request to the .NET server. The .NET server, the Blazor framework, is going to run some server-side code first, C# code, that will emit HTML that's sent over to the browser. That HTML will be rendered on the browser. JavaScript will be rendered on the browser, will be processed on the browser, and will continue to run. But in that kind of Blazor .NET application, the first code that runs is running server-side. So the initial spans will actually be emitted server-side before anything runs on the browser. So in order to be able to combine all of that data together, we need to make sure that the trace ID that starts off on the server and all the spans that are emitted on the server have the same trace ID that the spans on the client do as well. So in order to do that, the server injects a meta tag, and this is a convention that OpenTelemetry implements. It injects a meta tag with name trace parent, and the value here representing the trace ID and the parent span ID of the browser span in order to combine all of that data together. And that gives you user analytics in order to understand additional code that's running on the browser, things like clicks. Let's say you want to custom instrument canvas rendering or other components on the browser. You can do all of that, and you get a lot of resource timing as well. That's what this other diagram is showing, related to the performance of loading the actual website. Well, with that, we demoed Highlight as well to you. So we were able to show you how flame graphs allow you to understand which part of your code is slow. When you're looking at a full trace, you understand the sequence and time of code running across the server to the client and different parts of your web application. We also showed how we can understand latency by the source and by the service to be able to instrument a distributed application like the eShop example app, as well as further grouping things by additional attributes that we're collecting. So with that, I'd like to open it up to any other questions. While we have folks thinking about some questions, I had one that I'd like to answer, and maybe we can poll the audience for this one. How can data be associated across distributed services? Does anyone have a clue? I might have to call in Mike. Oh, can you run through how server and client linked with the WASM client? Sure. Okay, I'll do that right after I answer the distributed tracing question. So the distributed traces, when you have different microservices, the way that they can be associated is with the trace context propagation. So we showed an example of the trace parent meta tag. That's a way to combine something that happens on the server with the client. But if you're talking server to server, where an API request is made via gRPC, that can be associated by adding a custom header to the outgoing request to the second service. And then the second service reads that header and understands that, hey, this is trace ABC123. I'm continuing to emit spans with that same trace ID. So that's all handled by OpenTelemetry's trace context propagation. So can you run through how server and client linked with WASM client? Well, the WASM client runs on the JavaScript side in the browser, right? Or in WebAssembly. The WebAssembly loads in the browser after code runs on the server. So code running on the server, just like with the trace context propagation, is going to run first and is going to emit some sort of identifier into the HTML, or it can be actually setting a cookie onto the browser. Those are the two ways to do that. That value will be the trace ID that then will be used by the WASM OpenTelemetry client to emit spans on the browser. So that's how you can combine that data together. And if you have something that is using fetch or XHR requests on the browser in order to communicate with your server, let's say you have an API server side that is hit by the WASM layer, you would be communicating with that API via something like gRPC, HTTP, or WebSocket connection. And with all three of those, you can either, well, with gRPC or HTTP requests, you can just add a header, just like server-to-server communication. Or with WebSocket messages, you can inject the trace ID into the WebSocket messages themselves and run with that trace ID for each message. So the name of the game is to pass the trace ID between your different parts of your architecture so that you can maintain the context via the trace ID. And I am simplifying one thing there. The trace ID is part of it, but the parent span ID is also the other part of the trace context. Technically, with OpenTelemetry, there's a third flag that represents whether the span is recording or not, or the trace is recording or not. But yeah, the trace ID and the parent span ID are what associate data. So WASM client gets a UID when initially loaded. Exactly. Yep. And it gets it via a meta tag that's embedded into the HTML by the server, or if it's initiating a request to the, I guess it depends on where the trace starts, because you can have entirely client-side driven requests, right? You might not have a server until the WASM runtime loads and starts making requests to other services. In that case, the trace would start on the WASM side and propagate to those servers, again, via some sort of header, some sort of trace propagation. Any other questions? I did have a quick poll. I'm just curious, what languages are people familiar with OpenTelemetry in, and whether you found OpenTelemetry logs, traces, or metrics to be useful. Nice. We have someone familiar with JavaScript, OpenTelemetry, as well as the .NET OpenTelemetry ecosystem. Looks like logs and traces are both things that people have found useful. All right. Well, just share those results in case anyone else is curious. We had a few people answer. But with that said, I'll hand it back to Jay to wrap us up here.
Thanks, Vadim. So I guess before I kind of wrap things up, I just did want to close the loop on one item, which was about the differences between the existing tools in the .NET ecosystem and what you might have just seen with what Vadim demoed. I think the biggest two differences are, one, that a tool like Highlight is much more cohesive. And actually, Chris talked about this earlier on in the demo as well, where all of your observability resources, thanks to a lot of the propagation things that Vadim talked about in OpenTelemetry, automatically connect with each other. So if I'm looking at an actual session on the front end, I can connect that with what happens on the server. The second thing that I'll talk about that is a big difference is just the fact that there's not much front-end monitoring tooling in the Azure ecosystem in the current state. And that's kind of another reason to look at a tool that gives you session replay or gives you at least some metrics on the front end, which is normally called RUM, actually. So just something to keep in mind. But again, I think we tried to keep this more high level and specific to OpenTelemetry, and hope that was useful. So yeah, to kind of close things out, first of all, thank you for being here. It was fun to have you, and it looked like a lot of people were interested in asking questions, which is exciting on our end. Definitely take a look at Highlight when you get a chance. As much as we tried to keep this specific to OpenTelemetry, there are definitely benefits that Vadim kind of shared in terms of the demo. And then also take a look at our YouTube. So beyond just .NET, we also talk a lot about other languages and frameworks and how they integrate with OpenTelemetry. So there's other webinars as well as just videos there. In particular, if you go to our YouTube, on the front page, there will be a video on what is OpenTelemetry. And that'll just give you kind of a good overview if you're interested. And then lastly, our next webinar will be the week of October 7th. So almost exactly a month from now. So the date is not exact yet. We haven't completely finalized that, but it'll be that week, probably earlier in the week. And then lastly, before we go into any final questions, if you are interested in getting some highlight swag before the next webinar, feel free to fill out that form, and maybe we share it in the chat. Oh, Vadim already shared it in the chat. Yep, the form in the chat would be a good thing to fill out, because then we can kind of gather some information and send you some cool highlight swag. Mugs are the current highlight swag that we have on hand. So that's exciting. And then lastly, yeah, anyone have any questions to kind of close things out? Last minute questions, thoughts? Nope. Oh, it says this form doesn't seem to open.
Apologies. The only caveat is you need to be logged in, but if it's not working, let us just check on that.
Oh. Well, yeah, I guess. Also, maybe in the yeah, once you log in and we have your email, then we
Sorry.
can send
Now,
an email to you all.
give it a try again. Yeah, the issue is that it was restricted to our organization, so should be able to work now.
Got it. Nice. And then in terms of the email address part, if you don't mind checking that box, that'll give us an opportunity to reach out and get some more details to send some stuff over. Cool. Well, yeah, last opportunity to just copy that link, just so that we don't leave and you guys don't have access to it. But thank you again for coming by. It was fun to have you. This will be posted on YouTube if you want to share it with your colleagues. And yeah, beyond that, thanks for coming and appreciate your time. Any last things that I should mention, Vadim or Chris? Nope. Cool. Thanks, everyone. Take care. Have a good day, and good evening.
Thank you, folks.